Hi class, these are a few slides about the 4.6. Basically what I wanted you to see from this is that if they state the problem in log form, you are going to have to at some point convert it into exponential form. But you're going to use your algebra as always to isolate the needed term. And in this case, solve for d. Well, my log term has the d in it. So I'm going to try to isolate log d as I'm working through this. And I think you can read how I've done the algebra. Now then, when you get log of d by itself, now convert to exponential form. And the reason is I've got to get rid of the word log. I've got to ditch being in log form back to an exponential value. And you can see that I've just rewritten it up here. Express in exponential form, there's your conversion. It's going to look like b to the x is equal to a, and that's what I have down here. 10 to the x is equal to d. Can't take it any further because I have two variables. The next slide, this time you have exponential form. There are no log words. So you know you're going to end up in log form. And the reason is I have an x in the exponent. So there is your problem. You have to, and you'll notice where is x? It's in the exponent. So I'm going to isolate the e to the nx term and then flip it into log form. And that's what I've done here. I've isolated e to the nx. Now then, all you have to do is write natural log on both sides of the equation. That allows you to use your power property to bring the exponent down. And now I've just used my algebra to solve for x. And yeah, that's a lot of items there to move over. So algebra skills need to be top notch. Now we're going to be looking at exponential increase and decrease. We're going to be looking at a PERT form of the problem, but instead of a p, we're going to use the variable y sub 0. And y sub 0 just means the beginning or the initial amount. And y is going to be your future amount. Your k is going to control the increase and decrease of your graph. If k is negative, it decreases. Number 3, the initial amount of 100,000. You want to make it grow to 1,000,000, and you want that by the time you're 67. Well, we need to find out what interest rate it needs to be invested in. Again, your initial amount was 100,000. I have that written for you right there. And you want it to grow to 1,000,000. I just simplified. And now I've got my e to the 48k isolated. Drop the exponential form and go log. Take the log of both sides. I did not finish these. I'll let you do that. I'm going through these pretty rapidly. I'm sorry, but I have a limit on my YouTube account. So, oh, I love this one with the pythons. We're going to have nightmares. But I set it up. There's your beginning year, 20 snakes, 2009, 378 snakes. And these are going to be continuous growing. And there you are, your initial amount to your future value. You just set it up. And again, this is in exponential form, so I'm probably going to end up in log form. I've isolated my e. I'm going to take the natural log of both sides. Natural log of e is always reduced to 1. And there you go. Put that into your calculator and round. And you don't have to worry about Part C, but Part C, they want you to change it to 9 years. Number 5, decay or decrease. Again, we're going to stick with this formula because it's not half-life, it's just exponential decrease or decay. I'm comparing that equation to the half-life equation. They're very different. And the future is equal to the initial amount times e raised to the time over half-life. And I've worked that through, and I'll let you read that at your speed. The logistic curve, this is not going to be tested on Friday, but this one is one you may just put it into your calculator. And if you will read that problem, the next page tells you what to do with your calculator, your Y2, excuse me, and whoops, how to set up your window, and you just find the point of intersection. Any rate, I hope this helps, and we can discuss it more together in class tomorrow. Thank you.